Welcome everyone. This is Thoughtful Thursdays with Tornado IP, where innovation meets strategy and intellectual property. I am Dr. Sylvia Zepp, and we are here again with Dr. Mike Bowe to continue our discussions around the Pentagon license-free patents. And the title of our show is How Experts Read Patents, Learnings from the Pentagon Garage Sale. Today we're going to talk about when you first open a patent document, where do you start and why? What signals tell you that a patent is a real opportunity rather than just an interesting idea? How to determine what is the real invention looking at a patent and patent claims? What else is needed besides patents to bring a product to market? And how to triage patents from a large patent set like the Pentagon's to determine what determines serious evaluation. So Mike, we were talking about this patent set from the Pentagon in our previous presentation, and it turns out that the Pentagon has done a really good job actually starting to do the bucketing that we mentioned. Like when you have a really large patent set, somebody gives you 400 patents, it's very unlikely that you really need to look at the 400 patents, because there's going to be very distinct technology areas, and we discussed how some of those probably you don't care about as an inventor, as an investor, as a company. Certain one of those areas will be more interesting than others, so we discussed how bucketing them into relevant technology areas is a great way to just quickly scroll through. So actually the Pentagon has done this exercise for us already. If you go to this website or on their Defense Patent Holiday, you're going to see that you get to this link and you get to the buckets that they have already set up for us on energetics, materials, microelectronics, munitions, and other priority technologies. So if you're a materials science company, you would probably just click in here and you probably don't care about munitions. So I did this exercise and I get to a patent that I thought looked interesting. And again, the Pentagon is doing a lot of really nice work for us, maybe leveraging an AI tool, but they're actually summarizing where this, I clicked on a patent in that set, and this is actually a temperature regulating polymeric composites, and it summarizes the research, where it came from. It actually gives a picture of the inventor, tells us where their lab is located, and even lists some of the benefits, which is really nice, because that's kind of some of the high-level thing that a person reading a patent would be most interested in. So I wanted to show, like, let's say if this is what we first saw about this patent, then we can get to a PDF of this patent. The patent PDF is linked there, and the PDF cover page is what I'm showing here to start our discussion with Mike. So when you first open a patent, where do you start, Mike, and why?
It could depend on what I want to do with it. One of the things, I think it got cut off the top of this, is that this is a granted patent, not an application, which, depending on which search you do, we'll have that. So the application in the U.S., at least we'll start with U.S. and the year number and then something else, whereas U.S. patent granted has a number and often a letter B or B1 appended after it. And you see in that listing of references cited, they have that. So there's an old patent that this patent has cited, that 6207738B1, that's a granted patent, whereas a few lines down where there are year numbers starting up, those are applications, not necessarily granted, although they may have further future granted. So that's interesting to me, because as I'm reading this current patent, I want to know, is it actual and in force, or is it something that applied but has not yet granted and may not? So that's just a short thing. Another thing I would look at, often it's on the bottom half of this page, which I think you have on the next slide.
Yes.
Often the abstract is useful, because the title there's no rule about what the title can be. So sometimes it might just say a polymeric composition, but the abstract is written by the inventors at the time of filing, and it will have some one sentence to say 5 or 10 sentence description of what it's about. So that gives you some idea if it's still relevant, even more interesting to you, or maybe less so. That doesn't mean you would completely ignore it, but you might put it lower on your list for evaluating, for example. So that's a useful thing on page 1 of the patent. What does this thing include? Oh, there's a polymeric matrix and a thermoset polymer and a phase change material. So again, in the language of those 5 lines there under abstract in the bottom right, that tells you put you in the right frame of mind for what you're going to see.
Something I wanted to highlight, and again, I wanted to highlight here that we accidentally cut off the top area of this PDF, and on the top area you would very clearly see a very large patent publication number. In the US and most other countries, if that number ends with an A, then it's just an application and that has been submitted to a patent office, and that patent that gets examined by the patent offices across the globe wherever you applied, and once it gets granted, it's going to have a very different number and a B at the end. And the granted claims are very often really different because it got examined and they got some other form of that invention granted. So that's really important when you're looking at a patent to see if it was granted and then really evaluate the granted patent once you decide that this is a patent you really care about, because the granted claims are most relevant to you.
Right. Another thing that I do look at, you had your cursor right there on the midway down the left side.
Yes.
When was this filed? Okay, 2020 they filed this application, and I think we talked about it in a prior chat that a patent is not forever. It has a lifetime of 20 years from filing. There's sometimes adjustments to that, but this tells you it was filed in 2020, and the top line that's cut off shows it's granted. So there's still a substantial lifetime left in this patent if the assignee chooses to keep paying the maintenance fee. So it's that's one thing, as opposed to something that was filed 17 years ago. You may say, yes, this is interesting. I'd like to do something developed with it. And by the time the product got to market, there may not be that much protection left in the life of that patent. So this thing is, I would say, is relatively young. So the thing I look at and when I'm thinking of acquiring or licensing or otherwise partnering to use a technology. So
we talked about this last time we met in preparing for this discussion about how, typically a patent is applied for in multiple different countries where there's an interest in the market, securing the market. And usually you would see related applications in those different countries.
Yeah, we should get an example. This doesn't show it, that this was provisionally filed first in 2019, which I think that means the patent office in the US saw it, but it was not publicly revealed until sometime after the actual application. I'm looking at line item 22, the actual application filed in July of 2020, and that publishes sometime after, and they show that as January 28th, 2021. But you don't see, there's no record here of it being applied for in other countries.
Yeah, which is interesting, because certainly it could be if the Pentagon decided that this is some type of a material that they don't want to disclose, they could certainly stop publication, and they could even freeze publication for like a while, and in the meantime, it might be that they were not able to apply in other countries. That's a possibility.
Right. And some initial patent searchers sometimes say, okay, what are the other patents it cited? Okay, that's the top column. So when you're writing and filing a patent application, you've got to give some background to it. What else are prior methods to do related things? And that's the referenced documents in there. And you're somehow saying you're not completely inside of those patents, you have a novelty over those, but you give background to the reader and also to the patent examiner. So that's what that right side is. And often people ignore this, but it's interesting, the bottom right, they have other publications. It's not only other patents that are relevant to understand this invention. Sometimes there's other technical or commercial publications that can help you understand what's this field of the invention all about, and that's what the other publications are.
Yeah. Okay. So I think that covers all of the most interesting things that we typically look at, Mike. Do you want to? Let's move on to other parts of the patent that you would jump to. And I have a page here where I took a look at the patent claims. And so really the question we're trying to investigate here, what signals tell you that a patent describes a real commercial opportunity or just an interesting scientific idea?
So inside the claims, there'll be some degree of description in the patent, say 1 page to 100 pages of teaching the reader about this art and invention, but somewhere at the end you have to claim something. A patent really is staking out a claim to some, you call it property, it's intellectual property. So And this is somewhat narrow. I look at it's interesting. A polymeric matrix, okay, that's a lot of things, but it has to have an epoxy that includes bisphenol A and a curing agent, the amine. So if you made a polymeric matrix that did all the other stuff in here but didn't include epoxy, then it's not covered by this claim. So to me, that's a narrowing of the compositions for the polymeric matrix. Now, it can include the epoxy, but it doesn't have to be only epoxy and a curing agent amine. But it has to include those, see the various indents. A polymer matrix, yes. A phase change material, and there's a description of it, that includes a polyacrylic acid, and a layer of thermoset polymer to vent the phase material from leaking. So it tells you the things that it has to have to be in an invention. And if you have a polymeric composition that's missing one of those, then you're not inside that claim. So if you can make it something work just as well without, say, the thermoset polymer layer or the last line item, without at least 10% by weight of the polymeric composite, then this patent does not prevent you from doing that technology. There might be some other patent somewhere that does, but this one doesn't stop you from doing that.
So looking at this temperature regulating composite, what do you think is the real invention here?
I'm not an expert in phase change material composites, but I am aware that they often has some kind of phase change material in a matrix. So I think the first two are not unknown. The leakage is a problem, and I think in the possible benefits that were a few slides back that they disclose in presenting this as one of their options, something to prevent the phase change material from leaking. That's a known problem of these type of materials, and so that would be an improvement over others, and that wasn't solved at the first time such a material is made. So that to me is, that's interesting and new. I'd be curious to see how that works, how well it works, and does that solve the problem of leakage.
Moving on to just in general, the concept of government labs producing these types of patents. A lot of times these kinds of patents are impressive, but they never reach the market. From your experience in the industry, and again, like considering these patents as, we might have a license to it and try to monetize, try to bring it to market, what key pieces are usually missing?
From the patent, pieces that are missing. Sometimes they would be back in the body of the patent. They'll tell you, sometimes they'll give a very detailed example. We took these exact materials, here's whether chemical names or say it's a commercial name of stuff you purchased, and they demonstrated it with an example. Not every patent has a great example that shows you how well it was done and that it really does work. They may have a preliminary lab data or a small amount of lab data, but will it really work in whatever I'm trying to make? So in the abstract, I think they mentioned for comfort, maintaining temperature of buildings, etc. But would this really work for that? So it doesn't give that much information about it.
But as a company that's trying to make a material, let's say you got licensed to this, what else would you need to be able to do to get this to the market? I'm thinking about manufacturing know-how, facilities, like relationship with customers.
I'd want my team to have someone on it that knows about this Claim 3, because that to me is also interesting. It's an improvement. Sometimes heat transfer, and they say this higher up in the patent, is a problem. Just because you can regulate the temperature, you can't always move the heat as efficiently. And so Claim 3 says they include these thermal enhancers. Okay, maybe that's also an improvement that prior phase change material didn't have. And so I'd want to know about that. Are boron nitride one available, or are we able to make them? Are they available at a reasonable cost, or could you just make one without that's way bigger but be more cost effective? So I'd be curious to know about that, and would have someone who could give a technical opinion on, no, this is great, a little bit of that could really help the performance of this. I don't know it, but that's what I zoom in on. The further claims are even better sometimes than the ones above. So I'd want to know something about that.
So
and
in addition to
for example, cost prohibitive to get those materials, that's why you can't do it. You could physically make it work, but you, except for the most high-end, high-expense end uses, you might not be able to afford that. You could just say, again, I came from the building world, you could just make the wall a ½ inch thicker with more insulation, and that might be a better way to give energy efficiency if that's what the intent was.
Yeah, and I mean, certainly having access to the experts that are doing the innovation is going to give you additional hints. If you're a company that's trying to manufacture this, like what's a better material, like all of these things listed in the patent, you know, which one is better, which one can you get supplied, those kinds of things that inventors hopefully would have been thinking about. So definitely you would want to have access to their you know, group to find out. So moving on to you know, just the bigger scope of patents from the Pentagon, how to triage which patents you should really look at. So we have taken a look at high performance materials bucket, which has 45 patents, and I wanted to highlight to you you know, some of the things that Mike has noted. So Mike, do you want to talk to why did you notice these things? Why are these things interesting?
So I came from a chemical and material producing research background, so I imagined stuff like that would be not just military or aircraft uses, that could be more broadly household products or building materials. So, and then I think I highlighted in color some of them. So a flake coating that reflects UV. Well, UV is known to damage all kinds of materials, so something that selectively reduces UV but was still transparent. That's actually the title of their entry was interesting to me, and then this was actually good. Their bucketing also put one sentence descriptions of underneath it of what it did. Right, so and they envision that it could work in aviation, architecture, and more. So architecture is the millions of buildings across just this country and then possibly other countries. So that to me makes it more broadly possibly useful than just something that was for space and protection from UV there, where I know that's also important. So there you go. I don't know if you want to talk about any of the others. So those are the kind of things that it I liked this. I'm just zooming in on the middle one. The thermosetting resins. Okay, that's a whole lot of things. But a low temperature processing is a short. If it's thermosetting resin, you can't process it too hot because you'll cause trouble. So this actually enables it. And then the product has high temperature stability. And so it says it right there in its thing. Overcomes high processing temperature. All right, so that's useful. The bottom adhesive, I just like that. So an adhesive modifier that doesn't need primer, and that again is often if there's a multi-steps, but it takes a step out, and they even say it there, eliminates priming and enhances durability. And I also liked in their description, durable adhesion to substrates for epoxy, acrylate, thermoplastic. So there's multiple things it could work for, eliminating a step. So that to me sounds. In our earlier talk, Sylvie, we said, what would make this possibly commercially useful? If this material costs similar or a little more than other adhesives, but eliminates steps, that to me is always, I'll say, a green flag for potentially interesting as a developable product or process.
Certainly. So a few questions for you, Mike, for lightning round. Abstract or claims? Which one do you read first?
The search software I would use often would have the abstract up front, or the software company provides an abstract that's somewhat close to the abstract on the actual patent document. If I'm wondering, am I allowed to practice something, I'll look at the claims. I think I go to the claims more quickly than a lot of people, because if it claims something that does not stop me from doing what I want to do, if I'm, for example, looking at competitive stuff, then I would say I worry less about it. It could be useful parallel or adjacent art, but I go into the claims sometimes pretty quickly. The title, I think, is usually not very helpful. So the abstract, only a couple sentences, that's easy. And then the claims, first, depends on what I want to do. If I'm wondering if I'm allowed to do what's close to this invention, I look at the claims and see if it says, materials that have over 30% of some ingredient. I'm like, I'm working in the realm of single digits percent. Then it doesn't even bother me, or it's not going to interfere with my ability to do it.
And certainly, if you have a freedom to operate assessment to do, like this is how you look through some patents, and anything that is you find relevant, you would have a list of these and bring it to your attorney's attention, but you would want to look at the claim, the independent claims, and make that decision, not just based on abstract. Most common mistake engineers make when reading patents.
I think a common one would be when reading another patent. If you read a patent that says that's of interest and close to you, and it's a patent that's granted, and you have an idea to work that's not inside of there, you think, oh, that means I can do it. But really, a patent just allows the owner of that patent to prevent someone from practicing what's in the claims. But it doesn't mean I could work adjacent, because I have to look at the whole. Maybe there's a separate patent that would prevent me from making or using the technology that I want. So a given patent doesn't necessarily let you do something. It's a fence around something that keeps you out of doing it without permission or license from the patent owner. So a single standalone patent doesn't let you do anything. You can only practice stuff that's outside of everyone else's patents in the related art. And so it's a bigger search and analysis than just yes/no from the single close patent that you found.
Certainly. One clue in a patent that tells you that the inventor really understands the problem.
I think when they give citations or references to other things, and here's why it didn't work, and here's another way that someone addressed a need and it didn't work. And so they solve a problem that others, either through patents or open literature or whatever's been practiced from the day of filing backwards in time, and it doesn't work quite right or as well as it could because, and then we have found, there's often language that you'll see in a patent, or we have surprisingly found that this solves those known problems. So they understood it, they tried to make an improvement that was not already known to the world, and now we're disclosing that, as the patent requires you to do, to show you how you solved it, and then they'll claim something. So as opposed to imagining an improvement, but it's not like there's something really wrong with existing ways.
Next question, patents or trade secrets? Which matters more for advanced materials manufacturing?
If someone could decipher your secret on their own, that's dangerous because then they could do it, right? If, for example, they could get a sample of it after you start selling, reverse engineer and say, oh, this has these components that the world doesn't know to use together, we can make the same thing. And there's other actually risks there of them patenting, whereas if someone might decipher it, I better patent that. But if there's no way that they could decipher it, or you wouldn't have a way to police it, that is, how would you know that someone was infringing on your patent, then that you want to keep a trade secret. Because again, a patent isn't just give you protection of your invention, you have to tell how you did it. You don't have to tell your exact manufacturing process necessarily, but there's an obligation in getting a patent that you disclose what you think is the best mode for doing it at the time of application. So if they may guess it, then you could do well to protect it with a patent. If there's no way they would decipher your method of making, then maybe it's better to keep trade secret. As long as you can keep it secret, as long as you keep it secret.
In one sentence, what separates a patent that sits on a shelf from one that becomes a product in your experience?
A patent can protect a product if it aligns with other capabilities you already have in manufacturing, route to market, and customer need. Whereas if it doesn't have a clear pathway through all of those, it would not make it to a product.
So in a way, a lot of different elements of intellectual property have to jive together, not just a patent around market protection for an industry to monetize on something. You have to have manufacturing, you have to have customer interactions, you have to have a sales team. Like a lot of different things have to work together, and willingness to invest for a patent to become a product. Any other things that we might have missed in this discussion, Mike, around the Pentagon patents?
I think I did notice while looking through some of the other entries that they disclosed opportunities to collaborate, or they could give you data. And someone saying, here's a patent, you can license it, and you can have it for free for a couple of years. Enjoy. That's not as helpful as, by the way, our scientists actually did experiments, have data, and we can talk about sharing that with you, and we might even collaborate since we have either equipment or analytical methods, and that makes some of them to me more valuable or more interesting in that they have a running head start. So that was in this set of examples to try the garage sale of patents, if you will. Another one we didn't mention here, and I do this sometimes, is you're not always required to have a great example section in patents, but some ones that do, saying, here's the actual amounts of stuff we took, mixed, here's how we cooked it, here's how we applied it. Sometimes those examples are useful, and you can almost try to reproduce it exactly as written. And it's not as good necessarily as a journal article's experimental section, but that I also actually do look at. Especially when I see a new product by a competitor and I was curious, how did they do it? Oh, it's made under one or more of these following patents. And so it might give some hints as to what they're doing as compared to their product sell sheet or their material safety data sheets. They don't necessarily tell you what's in it. So that's sometimes helpful also to get an idea of what might be in a material trying to analyze, and I use that often for competitive intel.
One of the other things we discussed in a prior pre-discussion is how once you find a patent in a set like this that's of interest, you probably would want to try to use an advanced patent search tool, because once you know that a group of inventors is working in the technology of interest, you probably want to look at what else are they up to, what else they've done. So that's really easiest to do in a patent search tool. And you would put their name in there and their location, and if it's at the national lab, their location, and all those things can help you pull up a set of patents. And likely most of those groups don't just file one patent, so you want to kind of understand in perspective what the technology is, not just that one patent. And then the other thing that this type of advanced search tool might help you do is take a look at who that patent is actually assigned to. That's actually something that came to my mind in looking at this set is, are they all assigned to the Pentagon? It's very unlikely. They will be assigned to the national lab that the research came from. The Pentagon also has collaboration relationships with some universities. So you want to see who the assignee is, because that also, would have an impact on how the licensing is set up. Who owns that patent, and how what are the conditions under which they can be licensed and leveraged. So those are two additional things here.
Also that, and we saw it on the first page, this is a great patent. I'm curious because it's close to something I'm interested in. What did they cite backwards in time? And then the softwares will often let you see future citations. So say there's a patent that's right now is 8 years old. Okay, they had to disclose something. It's not like they just developed every idea out of nothing. And then if it's a good one, maybe people in the future cited it. And so you could see... what that is, and that gives you a better, more thorough picture of the technology area, and that's especially useful if it's something somewhat new to you. Should I get into this area? Well, here's what the state of the art is, not just one person's current invention. And that's a useful section of it again, and the good software tools let you lay those out in a usable way.
Thank you so much for listening. We hope in the future we can demo some of those search tools for you, or the way we leverage them. They certainly speed up assessment of a big patent set. This is Thoughtful Thursdays by Tornado IP. Follow us on Substack, and don't miss an episode. And you can find all of our previous episodes on tornadoipconsulting.com webpage for Thoughtful Thursdays. Thank you.